Hello viewers, welcome back to the another session of our data structure journey. In this video, we are going to learn what is a graph and how we can represent it by help of a computer system. Let's start the topic. So first one is we have to understand what is a graph. Graph is a non-linear data structure. As we initially starting, we know data structure broadly classified into two types. One is the linear, another is the non-linear. If the data stored in a one line format, then we say it is a linear. But if it is not in a non-line format, then it is called as the linear, not linear. So first point we learn that it is not a linear data structure. It is a non-linear data structure. A graph is composed of a set of vertices and set of edges. Next question, what is a vertices or what is a node? Node or vertices is nothing. It is a information we want to store. And edge or link is nothing. It is the association between the nodes or the vertices. Edge is same as the link. So graph is represented by G with V and E. What is a V? V is the set of vertices. What is the E? E is the set of edges. So graph is a combination of set of vertices, set of edges, or it is a combination of set of nodes and link. So this is a simple example. So this is node 1, 2, 3, 4, 5, 6, 7, 8. So these are the information and we store and the association between them. So these are the association we call as the edges or link. So what we understand right now, that graph is a consist of number of vertices, number of nodes and association or the relationship between them, which is called as the edges or link. Next, we have to understand what are the different categories of graph. So first category, on the basis of unit of attributes, it can be a single attribute graph or it can be a multi-graph, multi-attribute. So generally the examples are chemical or biological network where a vertex can only be one value. So if the vertex of the node has only one value, then it is called as a single attribute graph. So the examples are chemical or biological network. Multi-attributes means nothing node or vertices. If the node has more than one information, then it is called as the multi-attribute. Like the social network, where only one node or one entity or one vertices can play many roles. On the basis of unit of edges, it can be a simple graph or it can be a multi-graph. So simple graph examples like relationship in the Facebook network where one person can like one page only. It cannot be like more than one page. Next category is the multigraph, where the chemical compound, here the each edges represent the bond between two vertices or values. So here it is a example of the multigraph direction of edges. What is the edges? Edges are the association between the graph. So it can be undirected, means there is no direction is mentioned, means from A, the node A to B link is present, B to A link is present. So that is called as the friendship relationship in a Facebook. But in case of directed graph means the direction of the edges or direction of the link is mentioned, means it can be from one direction to another direction. Whenever it is both direction, at that time we call as it is a undirected, means it no director, both the direction it can be possible. So for the directed graph, the example are the follow relationship in the Twitter. Nature of application means where we can able to use. It can be a transactional graph, that is the biological and chemical data set, or it can be a single large graph, that is the social network or computer networks. Next one is the on the basis of density of a graph, it can be a sparse matrix or sparse graph, or it can be a multi-graph. So for sparse graph, the examples are transportation or road network. Consider the road intersect of time than the number of roads. In case of multi-graph community network, where the every person would be linked to the other person directly. So in this case, it is the multi-graph. So this is the different category of the graph. So the graph can be classified into number of ways depend upon the which category we want to differentiate. So what are the graph representation? In graph theory, a graph representation is a technique to store the graph into a mean of computer. How we can store the graph into a computer? To represent a graph, we need the set of nodes, set of vertices or edges. If it is a weighted graph, then we also need the weight associated with the each and every link. So there are basically three category of the graph representation present. First one is the adjacency matrix, second one is the indices matrix, third one is the adjacency list. So we are going to cover one by one all the three. The first one, that is adjacency matrix. It is a way of representing a graph in a matrix of Boolean. Means the matrix consists of 0 and 1. So here we convert a graph into such a format that the matrix is consist of only 0 and 1. If there is a graph of n vertices, then we have to create two-dimensional matrix of n cross n matrix, that is adjacency matrix of n to n. For example, there are four node present inside the graph, then 4 cross 4 means anyhow we have to create a square matrix, and the number of dimensions should be same as the number of nodes or number of vertices present inside the graph. If there is an edges from vertex I to j, then we have to mark as a 1, means value is present, edge is present, link is present. Otherwise, we have to represent the 0. It is the simplest way to represent a graph. So first one, we are converting the undirected graph into a adjacency matrix. Undirected means that there is no direction is given to the edge or to the link. What is a link or edge? Association between two nodes. So here there is no direction. That's why it is called as the undirected. So this is an example. There are four nodes present and 1, 2, 3, 4. And the link, this is the link, there is no arrow symbol. If any arrow symbol is present, then only we can say direction from one node to the another. There is no direction, that's why it is called as the undirected. No direction is given. Now we have to convert into the adjacency matrix. As we know, we have to convert the matrix which dimension? The as per the number of nodes. Here the number of nodes is 4. So we have to create the adjacency matrix size of 4 cross 4 two-dimensional matrix. So we have to convert into adjacency matrix, that is 4 cross 4. There are 4 n dimension is present depend upon the number of nodes. So here what happened? This is represent the node value. So if there is an edges from one node to the another node, then only we represent the value equal to 1, otherwise we represent the value is 0. It's simple. If there is a link or edge is present, then the value is 1, otherwise there is value is 0. So here how we are represent now, this is the first node, that the 1. From 1 to 1 any edges, is there any loop? No loop. So what happened? This value should be 0. Then 1, 2, 2. So this is the vertex I, this is the vertex j. Is there any link between from 1 to 2 node? 1 to 2? Yes, it is present. So its value should be 1. So we store the value 1. Then 1, 2, 3. 1, 2, 3. There is no link. If there is no link, the value is 0. Then from 1 vertex to vertex 4. 1 vertex to 4. Yes, there is a link. If there is a link, then we have to put the value equal to 1. Similarly, from node 2 to node 1, node 2 to node 1, yes, there is a link, so value is 1. If there is a link, the Boolean value is 1. If there is no link, then the Boolean value is 0. So 2 to 2, is there any link? No, there is no link from 2 to 2. So it is 0. Then from node 2 to node 3, node 2 to node 3, yes, there is a link is present. So it value is 1. Then 2 to 4. So node 2 to 4. There is no link is present. If there is no link is present, it is value is 0. Similarly, from third node, we have to calculate all the value. So according to the value, it stores the value. Similarly, 4 value is stored. So we can convert the graph into a adjacency matrix by help of the adjacency matrix. Now, so number of nodes is equal to number of dimension. So next example, it is for the directed graph. Previous example we covered, that is there is no direction, undirected graph. So here 4 node is present, but arrow is present. Arrow is present means the node direction 1 to 2, not 2 to 1. It can be traversed from 1 to 2, but it cannot traverse from 2 to 1. So there are 4 edges is present, 1 to 2, 2 to 3, 3 to 4, 4 to 1. Here direction is present, that's why it is called as the directed graph. So we have to convert into the adjacency matrix. First one, on the basis of number of edges, number of nodes, we have to create the two dimension, that the square. So here how many number of nodes? 4 node is present. If 4 node means 4 cross rows, we have to create a matrix. So we create a 4 cross 4 matrix. So if there is a link between from one node to the two node, then the Boolean value is 1, otherwise the Boolean value is 2. So for that, we are just represent the vertex. So now 1 to 1, 1 to 1, is there any link? No, so value is 0. 1 to 2, yes, there is a link, so value is 1. Then 2, 1 to 3, 1 to 3, no, there is no value, no link, so 0. 1 to 4, no, no value, so it is 0. Then we come to the 2. 2 to 1, no, 0. 0, 0. So only 2 to 3 is present. So 2 to 3 is 1, remaining are 0. Similarly, here what happened? From 3, 3 to 4 is present. Or there is no other path. So 3 to 4. Value is 1, remaining are 0. Then 4 to 1. So 4 to 1 means this value is 1, remaining are 0. So this is the way we can convert any graph into a adjacency matrix. So it is very easy. So whenever we go for implementation, then what happened? First, we have to create a matrix on the basis of the number of nodes. Then we have to store all the value equal to 0. Then we have to traverse. If there is a link present, edge is present, then only we have to put the value. Otherwise, nothing we have to do. So what are the advantages? Advantage is this type of representation is very easy and simple. Disadvantage because it leads lot of time and space to visit all the Novgorod road, because each and every time we have to visit is time consumption. So these are the advantages and disadvantages. Next category is indices matrix of graph. So here what happened, a graph can be represented using a matrix size of total number of vertices by total number of edges. In previous case, what happened? On the basis of number of vertices or nodes. But here it is not only the node, it will based on the nodes as well as the link. Both the thing is required here. It means that if a graph of 10 vertices and 20 edges, then we have to make a matrix of 10 cross 20. But in case of adjacency matrix, what happened? 10 cross 10 we have to make. But here we have to create a matrix of 10 cross 20. And the value it is presented by the 0, 1 or -1. Whereas in case of adjacency matrix, it is 0 or 1. But here what happened? It is 0, 1, -1. Here 0 represent the row edge which is not connected to the column vertex. Means if there is no edges present inside the the edge for the vertex, then only the value is 0. And 1 is represent for the rows edge which is connected as outgoing edges to the column vertex. So what happened? There is a incoming outgoing edges is present. On that basis, this is the representation. This type of representation generally we require whenever there is a directed graph is specified. It is specifically for the directed graph. And -1 is represent the row edges which is connected as incoming edges. So -1 means it is incoming. +1 means outgoing edges to the column vertex. So let us understand how we can represent it. So for example, this is our graph is given 1, 2, 3, 4, 4 node is present here, E1, E2, E3, E4. There are 4 edges. So here what happened? We have to convert into the indices matrix of which size? Number of rows into number of number of vertices into the number of edges. So 4 cross 4, because here the edges also same. So here it is a directed graph. So we have to convert into the indices matrix. So we create the adjacent indices matrix 4 cross 4. Then here the column is represented by the edges, row is represented by the number of vertices or number of nodes. So here first value is, that is node 1 E1. So what is the value? Value is 1, because it is a outgoing edges. If it is a incoming edges, then we have to represent the values 1. So for E2, for node 1, E2, is there any? No, no, there is no. So it is 0. For E3, it is also 0. For E4, E4 is the incoming edges. Incoming edges is -1 value. For node 2, for node 2 E1 is the incoming edges, so it is -1. For outgoing, it is 1, 0, 0. So all the value is stored accordingly. The incoming, outgoing, or is there any edges on it? So this is the representation of the indices matrix of a directed graph. So next we have to know what is the adjacency list representation of third graph. This is the third way to represent a graph in a data structure. So it is a linked list representation. We can say it is a linked list representation. Here what happened, an array of list used to store the edges between the two nodes. So here one array is represent to store the edges. The size of array is equal to number of vertices or number of edge nodes. An array of vertices which is included by vertex number, and for each vertex corresponding array element point to the single list of its neighbor or of the vertex B is represented. So let's understand how it's going to be performed. So this is the 4 node is present, node 1, node 2, node 3, node 4. So these are the edges is present. Now this is a directed edges. So we have to represent the adjacent list. Here what happened? We have to create a array, and the array size is number of nodes. So number of nodes is 4. So we have to create the array of 4 elements. So first node, second node, third node, fourth node. So all the node is represented, and now we have to represent the number of edges it is connected. So from 1, what are the node it can be connected? From 1 to 2 is connected, 1 to 3 is connected, 1 to 4 it is not connected, 4 to 1 is connection. How it represent? The link is from this node to this node. So from this node we can move to this node, from this node we can move to this node, we can move to this node, but we cannot move to this node because backward it's not possible, because it is a directed graph. So from one node we can traverse to the second node, and we can traverse to the third node. So here we represent a linked list. We store the value of 2 and 3. So we create a linked list. We store the value of 2 and 3, means from one node we can traverse the second node or third node. Similarly, from the second node, we can traverse to the fourth node, we can traverse to the third node. Node 3 and node 4 we can traverse, but we cannot traverse to the 1. So here we have to make a linked list. We store the value of 3 as well as the 4. So 3 and 4. For 3, only we can traverse to the 4. We cannot traverse to 1. We cannot traverse to 2. So for 3, only one node, that is the 4. So according to that, it represents. For the fourth node, for this node, we can traverse for 4 node to first node. We cannot traverse to the 2 or 3. So here only the linked list consists of 1. So this is the way we can represent the linked list. So here just see, if we go for adjacency matrix, we have to create 4 cross 4, where memory consumption is more. But here what happened? Memory consumption is very less. So this is the advantage. Here it saves lot of space, and insertion and deletion using the linked list is very simple compared to the adjacency matrix representation. But it has disadvantage that it allowed testing whether two nodes are neighbor or each other not, but it slower support to this operation, because we have to test whether there is a connection is present or not. For that, we have to perform the calculation so much. Hope you all understand the concept of graph representation in a data structure. Thanks for watching the video. Please subscribe the channel, like the channel, share the channel. Thank you so much.